Projection of vectors on diagonals, question 3. A square is defined by the unit vectors I and j. Find the projection of I and j on each of the diagonals of the square, right? So attempt this problem, try to sketch it first and then get your solution. Once you have done, then you can look into my suggestion, right? I'm also just giving you a suggestion for these set of problems and not really giving you solutions for these problems, okay? So I hope these hints will help you because you've done so many problems of similar kind already, right? So this is my xy plane and I and j are unit vectors in the direction of x and y respectively. So when we say a square is defined by unit vectors I and j, we're trying to say that this is my unit vector I and that is j. That means the magnitude is 1 here and the direction is of course along x and y. So that is the square which I have here. Now if this is my square, then what are the coordinate points of this? Let me call this point as P. So we have O here and P here. The coordinates are of course 1 and 1, right? That is how you get a square whose sides are equal to I and j. Now find projection of I and j on each of the diagonals of the square. Now the diagonals are, there are two diagonals in the square, right? So you can draw one like this, right? So let's do this. And the other one, let me do it in a different ink, and the other one will be this, correct? So these are your diagonals in the square. And what you really need to find out is projection of I. So let's go with I first on each of the diagonals. So if you want to do projection of I on this diagonal, which is increasing, then that green line. So from I point of view, your projection, and when we are saying projection, let's call it a vector projection, right? In general, when we say projection, then this is my projection from I to this particular diagonal, correct? Now the projection of I on this diagonal, what is that? They are in the same direction, correct? They're in the same direction. So is it same or different? This is what you need to figure out. And similarly, you can do for projection from j, correct? So that is the way you can do it. And if you're kind of confused about it, then what you can do is you can apply the formula straight away, right? You know what I is. So let's define I. When we say I, what do I mean? I vector is a unit vector and I is equals to 1, 0. And j, the unit vector, is equals to 0 and 1, correct? So we got two vectors. Now what is this vector? Diagonal. So diagonal vector, which one we are talking about, is OP for the time being. So we say OP is 1, 1. Correct? So let's work with OP first and then we'll find what is this diagonal, right? Now let me name this as QR. Okay, so let me say this point is Q for us and this point is R for us, right? So we'll define QR also. So QR is what? So vector QR. So vector QR is actually, if I say vector QR, that means it is I minus j. Do you see that? I minus j is vector QR. Let me write like this. I minus j. Right? So I minus j is what? This is I and that is j. So when I do I minus j, I get 1 minus 0, which is 1, and 0 minus 1, which is minus 1. So I get QR. Do you understand? So once we have ij, the two vectors, and we have the vectors on which we need to project, then it's a very simple thing. Now the only thing is you need to remember the formula. Now the projection of, that means let me say now projection of I on OP, let's say projection of vector I on OP, for example, correct? If you want to do this, then it is vector I dot of OP, and since we are projecting it on OP, so we need magnitude, OP dot OP here in the denominator, right? Times scalar multiple, and it is the projection on OP, so it has to take the unit vector direction in OP, right? This direction. That is what it is, correct? So that will give you the answer for I projection on OP, right? Now, similarly, you can find I projection on QR by replacing this and check what answer do you get, right? And do the same for J and figure out what answers you're getting and explain your answer. How are they related? Okay, that's kind of interesting. So I'd like you to do this question and understand what's going on. Thank you.